Wait. All right. You've been looking forward to this day. The determinant. Loved by no one. So when you have a 2 by 2 determinant, so notice that with the determinant, it doesn't look like it looks like a matrix, but it's not matrix, right? Because the matrix has the little bracket on it, right? This looks like an absolute value symbol, right? Just the two walls on the side. I'm hoping that people at home, you guys can hear me just fine. Yes? Leandra? Okay. So when you are doing a 2 by 2 determinant, to find out it's actually a value. So to find that value, it's going to be A times D minus B times C. So if you draw the Jesus fish facing to the right, that's what you would get. So again, it's going to be A times D minus B times C. So if you were to draw this right here, that's exactly what it would be. So if I was to take this same thing and bring it down, that's exactly what I would be doing. Man, there's a lot of people coming in. So when you do that, right, 4 times 2 is 8, minus a negative 1 times 7 is negative 7. So 8 minus a negative 7 will give you a 15. So again, a determinant gives you a value. So Kramer decided, hey, you want to find x, y, z? No problem. Kramer decided to throw a monkey wrench in things and saying, here's what you would need to do. The x value is going to be dx divided by d, and y value is going to be dy divided by d. Which means in this case, we will have to find not just d, we'll have to find dx and also dy in order to find the value. So you're like confused. How do I find dx and dy? So if you guys remember, when we write out two equations with two unknowns, we have a 2 by 3 matrix. Is that right? A determinant has to be a square. A determinant has to be a 2 by 2, a 3 by 3, a 4 by 4. Okay? So a determinant has to be a square. I repeat, a determinant has to be a square. A determinant has to be a square. Okay? So typically when we're given something, we're given it, if it's two equations, two unknowns, because we're looking for x and y, then we have a 2 by 3, which is obviously not square. Okay? So now I got to use other colors here. So to find d, what we'll do is we're going to use what's here. That is how you would find D. That would be my 2 by 2 and find the determinant for that. Doing the major diagonal minus the minor. And that is what I'm showing right here of how to find D. So notice that these 4 are in here, and that is just to find D, which I said to you guys before is this times this, the major diagonal, minus the product of the minor, or the other diagonal. So what's the appropriate follow-up question to this? If that is D, what is the follow-up question to it?
How do you find D of x and D of y?
How do you find dx dy? So to find dx dy, what you would need to do is you're going to take this right here. Remember that we have a x column and a y column. Is that right? What we would do is we would replace the x with the answers and do my determinant there. For dy, I will replace the y with the answers and do the same thing. So now I don't really need these anymore. So dx, I'm taking the answers and I'm going to replace it with the x values. So I'm taking the answer and replacing the x column with the answer, and that's how I'm going to find dx. So this is going to be the A13 times A22 minus A12 times A23. So same idea here. Same idea as here. And for dy, we're going to replace the y column with the answers. Let me give you guys some time to copy here because I know some of you guys are still copying, so let's just leave that alone. Or let me finish writing and then you guys can. So A23 here, A13 here. You guys have a couple minutes there to copy. So that's how you find d versus dx versus dy. D is just the x and y as your determinant. Dx is replacing the x column with your answer, doing that determinant. Dy is just replacing the y column with the answer and doing that determinant. A good note to have there. pan back out so you guys can actually copy the whole thing, but not just part of it. Not too bad, right? See, the thing I love about math is that most of the things kind of make sense. Somewhat, right? Because you're like sitting here going, why, who would come up with this thing? Like, how did they go, oh yeah, we can just do this and this will work. But when you're looking at dx and dy, you're like, oh yeah, replacing the x column with the answer would give me dx, called dx. That makes sense, right? So with that being said, let's go ahead and take this example right here, right? So let's take this example right here. It's in standard form on both of them. Let's convert that to a matrices. So go ahead and convert it to a matrices. And then write your three, because it's two equations, two unknowns, that means we got to write our three determinants. So write out your matrices, then write out your three determinants, your d, your dx, and your dy. I think that's the best way to do it in terms of practice. So write out the matrices, and then write out what your determinant for d would be, where your determinant for dx would be, and where the determinant for dy would be. Or just look at my notes, and it's all right there. And it looks so pretty there, too, doesn't it? It looks so pretty. Oh, the colors. Don't you just wish that other professors just do the same things? It'd be so nice. Other people want to join the party. Look at that. You can always do the math later. Do the determinants first. And remember, these are supposed to be just straight lines. Determinants are usually just like an absolute value sign, and not like, so like matrices look like this. Determinant looks like this. All right, so the matrices looks like that, right? So you see that,
Oh, okay.
and then the determinant looks like. See what I'm saying?
Yeah.
All
Notice the
right.
difference. Pointed it out.
You're like, I feel like I understand it, but I don't. Okay, let me just slam that on the table. That doesn't work. How do we do with the determinants? Do you get the determinants right? It wasn't too bad, right? Oh, this two here. That's the tricky stuff. And then sometimes we'll forget the subtraction. And that's that's not part of the negation, right? How do we feel? Is it a holy poop moment yet? I hope it's not. I hope it's like, all right, this is not too bad. It should be that. Because when we get to the 3 by 3, that's the holy poop movement. So to find our x, we've got to do dx divided by d. So dx is negative 65, divided by d, negative 13, and we get 5. dy is a 39, divided by d is negative 13, and we get a negative 3. So there is my x and y value. So the question is it better for me to do row operations, or is it better for me to do determinants? Hence Cramer's rule. So on your lab work, if it asks for Cramer's, show Cramer's. Okay? Besides that last lab work, right? There was Cramer. I think there was Cramer's on there, but you guys can just do whatever. I would tell you that with a 2 by 2, or I shouldn't say 2 by 2, with 2 equations, 2 unknowns, Cramer's probably easier. But row operation is pretty easy too. It's when we get to 3 by 3 is when things go nutty. Very, very nutty. So here, just so you guys see the color coding here, what I'm showing here is that this is what I'm thinking about when I look at this to get this. So you got to think of the two ends to get that. Okay? Now, I've decided that I'm going to go with staying consistent with the first row. Okay? That's what I'm trying to do. You will see in other textbooks that they might choose only the middle row or only the bottom row. And because of those rows being chosen is what these signs would change. Does that make sense? Because I decided on the first row is always going to be minus plus. Okay? I can't remember what it is on the second row versus the third row. But I know the first row is always going to be minus plus. So if you see it other places and it comes up and you're like, what? I thought it was minus plus. Realizes they're using a different row. Okay? But I'm going to stay consistent with just the first row. There's no sense on saying, hey, you got the second row they can do, and it'll be this. And it's the third row, and it's going to be that. I mean, now we're trying to remember 3 things to do one thing. It'd be kind of stupid, right? So let's just focus on the first row. And so this A right here is because I'm taking that first row with the first column. And where it's double crossed is A11. That's why I got the A11. And you guys can see that this is now left over, and that is what is in this box. Everybody see that? So this is first row, first column. First row, second column. First row, third column. So I'm keeping this row exactly the same all the way through. All I'm changing is this versus this versus this for those 3. Okay? So when I look at first row, first column, that's what's double crossed. That's why I have this. And this right here is what's left inside the determinant, because the determinant has to be square, right? A 2 by 2, a 3 by 3. Well, that's all I have left is if I cross that row and that column out, I only have a 2 by 2 left. And if I was to move this over to this here, guess what? I only have these two left, right? Well, that's where these two came from. And the double cross is right here. That's why that's right there. And if I was to move this over here, the double cross is right here. That's why this is this. And the 2 by 2 that's left over is right there, which is going into that box. And that's what I'm trying to show down here, just so you guys know. Questions on that? Do we need time to copy? Not needed? So again, this is just to find the determinant, a 3 by 3 determinant. So again, we're looking for a value. So we still have to do, okay, we got this times this minus this. I mean, this, yeah, this times this minus this times that, right? Minus this, and then the difference of those products. Plus this times the difference of those products. So, let's do it. Go bananas. Go, go bananas. Good luck. Here, let me give you this here really quick so that you guys can all see it. Give you guys a couple of minutes to do it, and now put it down. Look at this. If I was to cover that up and that up, what will be left?
I know those. I'm just having a break for like what to do after.
Oh, this times this minus this times this.
Oh, okay, minus. That's what I was thinking. How did we do with the determinant? For, I might have done something wrong then. Let's see if I did something wrong. So I know this. So I should have 2. And this is negative 1 times 6 minus 4 times negative 2. 5 here. 3 times 6 minus 4 times 5. 0 times 3 times negative 2 minus negative 1 times 5. This should be 0, right? Or 0 times negative 1. Let's just do that. That's 18 minus 20, so it should be 5 times negative 2. This is 2. This is negative 6. Positive 8. So that's positive 2. Is that right? So this would be what? 4 minus, or no, 4 plus 10. So one of the things for you guys is that for some of you, you might think that this is way too much to write down to try to figure out. Like, maybe I can just type this all in the calculator. You can. You absolutely can. But I'm going to say this to you right now, because I'm thinking about when I was in your seats, right? How you guys would be thinking, which is just type this in your calculator, I get a done, right? Get in the practice of actually doing this work. Because for some of you guys, you're going to go along with math. You're going to get to Calc 1, Calc 2, and so on and so forth. I would tell you that Calc 1, Calc 2, Calc 3, I did math in this direction. When I got to diff EQ, this wasn't enough space. I had to do it in this direction. And there was nothing to type into the calculator. I had to keep it organized and do the work. Does that make sense? So for me, it's better off when it's simple things like this to do the work, because when it comes down to it, it's like, okay, no big deal. I did the simple things already. I can do the more complicated things when it comes into it. Okay? So do the work. All right. So understand that that is just for D. Now, for the problem that I just gave you, you can't find dx, dy, dz, right? So for the problem that I just gave you, you can't find dx, dy, dz because this is not 3 equations, 3 unknowns. I just gave you a 3 by 3 and say find the determinant. But if it is 3 equations, 3 unknowns, as you guys can see, it would be a 3 by 4 matrices. Exactly the look I was looking for. And dx, x is dx divided by d, y would be dy divided by d, and then z would be dz divided by d. The d is still the same, right? It is the x, y, z matrices. Dx would be replacing the x column with the answer column. Dy would be replacing the y column with the answer column, and dz would be replacing the z column with the answer column. So it's still the same exact thing, right? It's not like, holy cow, this is totally different. So again, D is just what's in here. That is how you find D. Again, to find dx, however, I'm going to replace the x column with the answer column. For dy, I'm going to replace the y column with the answer column. And for dz, I will replace the z column, already replaced, with that. So my question to you is, do you want to go through all of that? Or should we try it in this problem here? So all I want you guys to do is to write out your d, your dx, your dy, your dz, and give me your your three determinants, three mini determinants, the 2 by 2s. So kind of like, so I want you to write this and then write your three mini ones, right? Just so that it looks something like this right here, but with numbers. Is that fair? All right, so write your D, write your three mini, write your dx, write your three mini, write your dy, write your three mini for this problem here. Okay? You don't need to solve anything because I think the setup is the most important part. If your setup is wrong, then we're in trouble. In a lot of trouble. Bad setup means for sure guaranteed wrong answer. Guaranteed. I was expecting James to walk in, but James might be just walking to trig. Do it with the numbers. Go to the next page and do it with the numbers. No, I mean, because doing that is harder. Doing the numbers is a little bit easier to see. So just do it with the numbers, that's all. So just turn the page and do it with numbers. Does that make sense? How do we do? Good? Not bad, right? Bless you. It's kind of like just, what's the right word? Monotonous, tedious, that's the right word. It really is just tedious, right? It's not hard, it's just tedious. How do we do? She wants the answer. I want my stinking answer. I'm sure it doesn't hurt if you just did this as well. Let me see if this works better. If that setup is right, then chances are you're going to get the right answer. And I believe, if I'm correct, you should end up with 5, or no, sorry, -5, 20, 20, and 0. But I figured that U-wise, we have another section to go through, which is the operations with matrices. I don't have a problem with you telling me if something went wrong here, or for me to like work one of them out. I don't have a problem with that whatsoever. How do we feel? We're okay? Questions so far? For the people at home? Any questions for me? You really want to know the answers, don't you?
No. Could you work out D?
D? Actually, you know what I should do? Let's do this. So it should be positive 5. Is that right? Is that what you were wondering too? No.
No, I messed up with something, but it's because
Do you guys want me to keep on going?
Professor,
Yes.
for
Wait, wait. Is that what you're saying? Because I forgot those numbers that you forgot before. Remember you forgot those numbers in front? I totally forgot about those numbers in front. So my notes are totally wrong. Well, I know that last one is 0 for sure. You got -9 and +4 though. You shouldn't get +4. I mean, you should get +4 but -9. Because the coefficient should be -3, right? So it is -5. You see that, Andrew? I totally forgot too. I totally forgot those numbers in front.
I was like, damn.
I'm just human too. I can make mistakes.
I was like, there's what is
So don't doubt yourself.
Because at first I got -13 because I forgot to do the negative. So then, I ended up with 9 and the 4 and I accidentally ended up with that. So then I fixed it again, -5. And then you showed me +5. I was like, no. -5.
Yes, Travis.
for dx,
Yes, sir.
-20, but
Let's work it out. Let's work it out because I'm kind of liking what you guys are doing to me here. I'm enjoying the stress me out right now. Let's go ahead and do it. And we just, hey, on the dx. Okay. '20 is right.
I guess I had formatted the 4 -15 wrong because I put it 4 -15 minus -12, and I just got
Gotcha. Gotcha. Remember, it's always going to go in this way, right? So it's going to be this times minus that times that.
Okay, so we go. Okay, so we go to the right down first, and then we go.
The major diagonal first,
Okay.
right? So if you draw the fish facing to the right, it will help you. If you think of it that way.
Thank you.
No problem, dude. That's what I'm here for. To either squeeze the confidence out of you or give you confidence, one or the other, apparently. Any questions on dy? We're good with dy? You got 8. Let's take a look. 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 This is the difference between you guys and the other students in the other classes. The other class is like, okay, well, let's move on. And then you guys are like, no, 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 no. I want to figure this out. That's still 20? It's all good. That's why we're doing this. Because the answers I got on the notes really was me going, what do we got? I didn't actually do the work. You got it? Do we feel better? I should have known better not to move on. All right, operations. That means we got to add, subtract, multiply, divide. All right. Adding is not bad. Adding and subtracting is not bad at all. Okay? However, you know how like adding polynomials, you had to have the same base, same power, right? Radicals had to have the same index and the same radicand, right? Well, with matrices, you must have the same dimensions. So To add to a 2 by 3 matrix, you have to have a 2 by 3 matrix. It can't add to any other size or any other dimension matrix. And once you have that, you're just going to add or subtract the corresponding matrix. That's all. So if I took this matrices, right, B, let's say, let's make it pink. If I was to take this and stack it on top of A, and if I was adding them, that means A11 would add with B11. A12 would add with B12. A13 would add with B13, right? Corresponding. So if I was to lay on top of each other, they would just add the corresponding ones. That's it. But number one, you got to make sure that they're both a 2 by 3. If A is a 2 by 3, B has to be a 2 by 3. If B is a 3 by 4, you can't add them. Just like an x cannot add with an x squared. Same difference. Okay? So that's the reason why I wrote this here. But I figured if I just took that and actually moved it over, stacked on top of it, you could see what corresponding meant, right? Not the fact that you don't know what corresponding means, but it's nice to see it sometimes. Subtracting, same thing. Instead of adding, it was subtracting. Still corresponding. So obviously, whichever matrix is labeled first, that's the number that goes first. So that's how you determine if that element is, or entry is negative or positive. Right? Is someone that popular in this class, or is it someone upstairs with their phone on the floor? Because that's what it sounded like, right? It sounded like it came from up there, and I'm like, apparently someone left their phone on the floor. Is that okay? So just so you guys understand something, if you guys decide that, hey, I want to check to see if my answer is right, okay? Online-wise, with Desmos, there is a matrix calculator. It's just not in test mode. Again, the matrix calculator is not going to help you on the test, nor your lab work. Okay? Just so you guys understand. You can check your work, but it doesn't help you because you still got to show the work anyways. So if it's a determinant, guess what? You're going to have to show all the things that you already saw. Just so you guys understand, I'm much less concerned about what we know in these cases right now. Does that make sense? Because the tedious work is going to explain, like, it's going to tell me you know what's going on. Right? I don't know if ChatGPT can extend things out to you that way. Okay? And plus, if you don't actually do the work on the lab work, you will fail the exam, period. And you will bomb the final as well. Okay? So if you don't actually understand what's going on and you're like, I'm just going to cheat with PhotoMath or whatever, chances are you're going to bomb the exam and then bomb the final exam, just so you guys know that too. All right? So in a matrix calculator, the number one thing you're going to see, because you keep on seeing these A's and B's, you actually have to select a letter, A, B, C, D, okay, which is the name of that matrix. You're going to tell what size it is. That's why the first thing we taught about matrices is how to tell its size. These are 2 by 3s. Rows first, number of columns. 2 rows, 3 columns. When you enter that, it will give you a matrix of that size. Okay? Actually, I can probably show you guys this, actually. It's not on the do I have regular Desmos? Let me see. Yeah, let's just do that. Desmos matrix calculator. All right. So if I hit, so you see the A, B, C, D, E, F, G, and then inverse. If I hit new matrix, notice I labeled it to be A. And it shows a 2 by 2 already. So in the TI, same thing. Let's say I do 2 by 3. And automatically it already sets that up for me. Then I enter everything. But notice that this is labeled as A. Okay? So let's just do this. I don't know what this is going to do. Okay? So if I come here and I want to do something with that, like if I want to do A squared, I got to hit A and square it. Obviously, there's an error. Or let's say I got to find the inverse. So A, find the inverse of A, hit enter. Can't do it because inverse has to be a square as well. Okay? I can find a determinant. Well, I can't find a determinant of A because determinant has to be square. Right? If I do a RREF of A, then there it is. See what I'm saying? So all of those things are still there. So you can find a determinant of a matrix. So you could actually enter that in and see if your numbers are correct. So we could have done that on the calculator to see if the -5, 20, 20, and 0 was correct. Okay? So, but again, you got to name them first. So when you hit matrix on your TI, you have to go, I select A, what size it is, enter the numbers. B, what size, select the numbers. Then you go on the main screen, you say A plus B. Okay? And then that's what will happen. All right? All right. So they're commutative, commutative, and associative properties stand. So it doesn't matter if you do A plus B or B plus A. Still the same thing comes out. Associative property means it doesn't matter if you add 2 to add to the third or add the last 2 and add to the first. It still comes out to be the same. So why don't you guys add these together or subtract them together? So go ahead and write down those two matrices really quick. And I'm going to show it to you on the matrix calculator. So just write down those two matrices. Three, 3, -2, -2, 5, -6. So add them by hand, and I'll do it over here. There we go. That looks much better. How did we do? 403, -4, 5, -2. 2, -6, 7, 0, -5, 10. So notice how I have to use it as A plus B and A minus B, given the fact that these were labeled A and B. Okay? Next thing is called scalar multiplication. Scalar multiplication is just like distributing, right? So if we were to do 3 times x plus 5, what would you do? You distribute it, right? The x gets the 3, the 5 gets the 3. Is that right? This is exactly the same thing, but this is now, instead of distributing, it's just called scalar multiplication. So, if I got some n times A, that means I want n times this matrices. That means every single entry in here gets n. It gets multiplied. That's it. So no big deal, right? So every single entry is going to get that scalar multiplication. It's going to get distributed. And the properties is just saying, if I had a scalar or a number in front called k and a number in front called h, it doesn't matter if I multiply h and k together and then multiply through the matrices, or I can multiply one number through the matrices and then multiply the other number through the matrices. I should still get the same thing, which makes sense. It was addition. I can multiply one into the matrices, the other one through the matrices, and add the two matrices. Or I can just add the two numbers and then multiply through the matrices, which I think would be easier. But you do you, boo-boo. So if I was to use the same exact matrix, or the two matrices, and say find 2a minus 3b, right? I'm still having, the A is still the same matrix, B is still the same matrix, but now I'm just doing 2a minus 3b. So that means I got to multiply 2 through the A, 3 through the B, and subtract them. Or 2 through the A, negative 3 through the B, and add them. That both of those work, right? And on the calculator, all I got to do is say, hey, I want 2a minus 3b. And I'll get my answer. But of course, here you're going to have to show all your work, right? You got to show the 2a, you got to show the 3b, and then you got to subtract them. So not too bad. But the key is still the size or the dimensions of the matrix have to be the same. If they're not the same, you can't add or subtract them. Oh, here's another colorful one. Oh boy. Okay, let's talk about multiplying. So it says, in order for you to multiply matrix A with matrix B, the number of columns in A has to equal to the number of rows in B. That sounds really confusing. So here's what I'm going to tell you. So you see that A is a 2 by 3. You see that B is a 2 by 3. Yes? Let's put the 2 by 3 times 2 by 3 together. If these two inner numbers are not equal, then they cannot multiply. So if these two inner numbers are not equal, you cannot multiply. So because there's a 3 and a 2, those two cannot multiply. Help you out a little bit. Easier to see instead of around the screen. So if you look at this one here, this is a 4 by 3. This is a 3 by 2, right? If I put them side by side, does the two numbers in the middle match? Yes. The resulting is the outer numbers. So 4 by 3, 3 by 2, 3 matches. That means there's going to be a 4 by 2 that's left over. Does that make sense? So the first thing we got to determine is what is the size of that multiplication. So when we put these numbers together, look at this. Voila. These two numbers match. These two numbers match. We celebrate, and the resulting matrix is going to be a 4 by 2. Are we okay so far? All right. So now this is the most colorful notes you're ever going to see. So I said we were going to result at 4 by 2. Is that right? So first, I got to determine what size of my matrix is going to be. I said 4 by 2, so I automatically draw my matrix to be a 4 by 2. Okay? Now the question is, what goes there? What goes here? 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 Right? So you agree with me that this right here would be, if I was to look at one, it would be like A11. Right? If I was to look at regular matrices, that'd be A11. Row 1, column 1. Guess what I just did? I want to take row 1 of the 4 by 3 with column 1 of the 3 by 2, and I'm going to multiply corresponding ones and adding them together. So this times this plus this times this plus this times this. That's why I highlighted it the way I did. Make sense? So to get this one, this is what? Like orangey yellow? Well, that corresponds with this orangey yellow. Okay? Because this right here would be A21. So row 2, column 1. A31. Row 3, column 1. A41. Row 4, column 1. Right? So I made sure that what I wrote, what I highlighted here is corresponding exactly here. So this one here is this one here is this this one here is this, and this one here is this. Right? So everything on the right is on the right side, everything on the left is on the left side. Is that fair? Okay? So please try that out. Well, you could try it out here. However, I'm looking at time right now, guys. So I want you guys to try this example out. And the work is in the notes. All right? However, I feel like we got to talk about this before we leave. Before we leave, we should talk about this. So there is such a thing as a matrix, as the inverse of a matrix. Okay? So, however, to find the inverse, it has to be a square. If it's not a square matrix, we cannot find an inverse. As you notice with the calculator, when I did an inverse of a 2 by 3, it gave me an error. Gave me that little tiny cosine triangle, saying, can't do it. Because it wasn't a square. It must be non-singular. So when you see that in the directions that this is a non-singular matrix, means that I can find the inverse. It just means that the determinant is not equal to 0. Okay? So, how do I find the inverse? To find the inverse of this right here. So we see that this is a 3 by 3 matrix. Is that right? Awesome. So we're going to leave the left side to be that right there. Okay? On the right side, we're going to put in the identity matrix. You're like, what's an identity matrix? So we call this I sub 3. Meaning we know that this is a 3 by 3. So the identity matrix is going to be a 3 by 3 identity matrix. That's all that sub 3 means. Which means it's going the major diagonal is going to be 1s, and everything else is going to be 0s. That is the identity matrix. So 4 by 4, major diagonal is 1s, everything is 0s. 5 by 5, major diagonal is 1, everything else is a 0. Right? 2 by 2, 1, 0, 0, 1. Okay? We okay so far? Are we sure? Okay. So, this is how you find your inverse. Ready? So remember on Tuesday, the first thing we were trying to do was REF or RREF. Is that right? And when we did RREF, the left side became 1, 0, 0, 1. Or I should say, the major diagonal became 1s, right? And everything else became 0s for RREF, right? That was the identity matrix. So what we're going to do here is that we're trying to get this side to have that. So we're going to do row operation, focusing on getting this side to be 1, 0, 0, 1, 0, 0, 1, 0, 0. Okay? So that's what we're trying to do. And whatever result happens on this side, that would be your matrix, your inverse matrices. which is actually going to be, it's going to end up being like this. Did you want me to walk through it? Okay. There's one other thing I want to bring up first of all. Before I walk through it. And the reason why you want the inverse matrix is because of this. Here, let me just skip to it. Let me just bring it up to here. So if we were to use the inverse matrix to find our equation 3 unknowns, okay? Remember how we controlled this into a matrices, right? And if we were to put this in here, we would have 1, 1, 0, -1, 3, 4, and then 0, 4, 3. And the answer is 1, -1, -1. And the variable x, y, z would just be here. So one of the things we talked about was if I was to multiply two matrices, right? This is a 3 by 3, 3 by 1. What's my resulting going to be? 3 by 3 times 3 by 1, we're going to end up with a 3 by 1, isn't it? So when I multiply these two guys, I'm actually going to get this right here. Which is equal to this answer. So if I did A times B is going to equal, A times X, I'm going to get B. Okay? Now, typically, you would sit here and go, oh, if I wanted to solve for X, I just divide by A. Right? Except with matrices, that doesn't work. Notice that we didn't go over dividing. Because there's no dividing. Okay? So in order for us to get rid of A, we have to multiply by the inverse of A. If we multiply the inverse of A here, this goes away, which means we got to multiply the other side by the inverse of A. So the inverse of A times B would give us our solution for X. All right? Now, I see the time. I have no problems with you trying the best you can with this, the inverse part and this part, and then bring your questions to me next Tuesday. Is that fair? Because I see the time. Obviously, I don't want to hold you guys any longer. All right? So bring all of your questions about inverse matrices and how to deal with the linear equations, all right, on Tuesday. So ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. See you guys on Tuesday. Later.